Okay, so this lesson is ionic bonding part 2. It's going to follow on from yesterday's lesson. And if you haven't already, just scroll down and answer the do it now questions from the previous topics. They're just below the video. Answer them first and then come back here and we will carry on talking about ionic bonding. So in the lesson today, we're going to recap what we looked at yesterday. We're also going to take it one step further and look at a slightly more complicated example of ionic bonding. And then we're going to look at an exam question and we're going to figure out the best way to answer exam questions about ionic bonding. So we'll start with a recap. We're going to look here at bonding together sodium and chlorine, and we're going to make sodium chloride. So remember that metals always give away their outer electrons to form a completed outer shell. And remember that non-metals like chlorine will always take extra electrons to fill up their outer shells as well. So in this example, sodium has 1 on its outer shell, so it will release that electron and that will be picked up by the chlorine atom, making both atoms stable with a full outer shell. And I'm sure you remember from yesterday, that means that sodium will now form a positive ion because it's released and got rid of 1 negative electron. So sodium becomes +1 or +1. And because chlorine has gained an electron, it will form a negative ion, a chloride ion with a charge of -1 because it has 1 extra electron. And because our two ions are oppositely charged, one negative and one positive, they're now going to attract each other because opposites attract, and this will form the ionic bond. So it's the force of attraction between the oppositely charged ions that makes them bond together. Now, one thing we didn't talk about yesterday was the square bracket. So if you look at the ions on the screen now, you can see that they've got square brackets around each of them. And in the top right-hand corner, we've got either a positive or a negative sign to show us the charge on our ion. So if you see what looks like an atom or an ion with square brackets around it, that is telling you that you're looking at an ion. And if you're drawing an ion, the correct way to do that would be to draw it with its electrons arranged correctly and then put square brackets around it with your positive or negative sign in the top right hand corner. So you can see there in that reaction we've taken 1 sodium ion and 1 chloride ion, we've bonded them together ionically and we've made the ionic compound sodium chloride. So everything we've looked at so far has been a recap of yesterday's lesson. So we're going to move on now and look at an example, a slightly more complicated example, calcium chloride. So we're going to do exactly the same thing, but we're going to use calcium as our metal atom and chlorine as our non-metal atom. So the first thing to do whenever you're trying to figure out one of these reactions, simply draw out your two atoms. So we've got our calcium atom there. There's a slight error in that PowerPoint. It actually says that calcium has an atomic number of 22. It's actually 20. So calcium has 20 electrons, but the arrangement there is correct. So the 20 electrons will be arranged as 2882. And our chlorine atom has got 17 electrons and they'll be arranged 287. So we've just followed the normal rules there for which electrons go in which shell. Now, once we've drawn that out, we need to ask ourselves our first question: how many electrons does the calcium need to lose? And if we look at the outer shell of calcium, we can see that it needs to lose 2 electrons in order to have a full outer shell. And then if we look at our chlorine atom, we need to ask ourselves as well, how many electrons does chlorine need to gain to pick up to give itself a full outer shell? So you should be able to see that chlorine only requires 1 more electron because it's already got 7 in its outer shell. So this gives us a slight problem because the calcium atom wants to get rid of 2 and the chlorine atom only needs to pick up 1 of those 2 electrons. So in order to make sure that all of our electrons are used up, we're going to need 2 chlorine atoms for our 1 calcium atom. And that will allow each of the chlorine atoms to take 1 of the available 2 electrons given away by the calcium. And that will mean that our calcium atom can still give away and lose 2 electrons, and each of our 2 chlorine atoms will simply take 1 each for themselves. So we'll have no electrons left over, and every atom will still have a full outer shell. And here you can see our ions with their square brackets. Notice the calcium has a 2 plus in the top right corner because it gave away 2 electrons to become positive 2. And each chlorine ion only has a minus sign. You could put 1 minus, it means the same thing, but each of those has a minus charge of 1 because they gained only 1 electron each. And because they're oppositely charged, our chloride ions will be attracted to our calcium ion because they're negative and positive. And also remember that we've got a total of 2 positive charges and a total of 2 negative charges because we have 2 of the negative chloride ions. Now we also want to know what the chemical formula is for calcium chloride. And we know that we've used 1 calcium, and calcium has the symbol Ca, and chlorine has the symbol Cl, but there were 2 chlorines, not 1. So the correct chemical formula for calcium chloride will be CaCl2. And remember, because we have 1 calcium and 2 chlorine, the 2 is a small 2 that belongs only to the chlorine. And that will then form itself into a lattice structure, which will involve millions and millions of positive calcium ions and millions of negatively charged chloride ions. So hopefully you followed that. That really is pretty much all there is to ionic bonding. What we need to do now is I want to check that you've understood that by giving you some of your own examples to work out. And then we're going to look at exam questions and strategies for answering exam questions where you're asked to describe what happens when things ionically bond. I'm going to give you 3 different examples of compounds that will bond together ionically, and your job is to do 2 things. First of all, I want you to draw out your atoms for each pair, work out how many electrons each have got and how those electrons are arranged, and then I want you to try and work out how they would bond together ionically. So you'll need to know how many of each ion you need to complete the ionic bond. Once you've done that, you'll then be able to work out the chemical formula for that compound. So just like we had 1 calcium and 2 chlorines, we know that that makes calcium chloride, which must be CaCl2. I want you to do the same for each of these 3 pairs. Now it's going to be difficult for you to show me your drawings, so you don't need to submit to me your drawings of the atoms. You just need to use that yourself to work out what the formula will be. And I want you to put the answer for each of your 3 formulas in the questions below this video on the form. So the first one I'd like you to try is lithium oxide. So that's lithium bonded to oxygen to make lithium oxide. So draw them out on a bit of paper, work out how many ions of each you need, and then go down to question 7 and choose the correct chemical formula for lithium oxide. And the second one I'd like you to try is magnesium fluoride. So that's magnesium bonded to fluorine. So do the same thing, draw that out on a piece of paper, work out how many of each ion you need, and then go down to question 8 on the form and select the correct chemical formula for magnesium fluoride. And the last one for you to try is magnesium nitride. That's magnesium bonded to nitrogen. Work out how many of each ion you need for magnesium nitride and then choose the correct answer from question 9 on the form below the video. Okay, so the last thing we're going to do for this lesson is we're going to look at this exam question. So this was taken from a previous chemistry GCSE. So it's asking you to use information in the table to describe the structure of sodium and fluorine atoms and how they combine to form sodium and fluoride ions in sodium fluoride. And it is a 6-mark question. Now, whenever you get a 6-mark question, you need to try and decide in your mind where the points are going to come from. So it says in the question that you need to describe the structure of the 2 atoms and talk about how they combine. So we're going to split this question in half and we're going to try and get 3 points for talking about the structure of each of the atoms to begin with. Now we're going to talk through this question together, but I'm going to get you to answer it on the form below the video, and you might want to pause and do it in stages as we talk about it. So if we're splitting it in half, we want to try and get 3 points for discussing the structure of the two atoms before anything has happened. So forget bonding them together ionically. Let's just talk about the atoms themselves. So what things could you talk about? You could talk about how many electron shells each of those atoms have got, how the electrons are arranged, how many electrons they have in their outer shell, and you could talk about the charge on the atom. So compare the number of protons to the number of electrons. Now, if you do that for both the sodium and the fluorine atom, you will straight away have scored 3 marks out of 6 before we've even started talking about how they turn into ions. So pause now, go down to the question below the video, the last question, and write the first half of your 6-mark answer. So do that now. When you've done that, come back and we'll have a look at how we can get the final 3 marks. So now to try and get our second 3 marks, we need to talk about how they combine to form sodium and fluoride ions in sodium fluoride. So you're going to want to talk about which atom releases or loses electrons and which atom collects or gains electrons. You're also going to want to talk about how many electrons are transferred, and you'll want to talk about the charge of each ion after those electrons have been lost or gained. And the last thing you'll want to do is just to explain why, once they've become ions, why they're attracted to each other in the first place. So have a think about that, add that on to the end of your 6-mark answer. I'm sure then if you've included all of those points in your answer, you should be able to get 6 out of 6. And remember, in a GCSE exam, just like an end of topic test, getting an extra 6 marks, the difference between not answering this question and getting 6 out of 6 could easily mean you move up by an entire grade. So it makes a huge difference getting 6 out of 6 on a 6-mark question. So when you've completed your answer, you can submit your form. That is the end of our lesson today. Email me if you've got any problems. Don't forget there's a support session tomorrow afternoon at 3:30 till 4:30. You can always drop into that session and ask me any questions about this lesson or this topic or anything else that you are stuck on. Okay, good luck. I'll speak to you soon.